Hello friends, I welcome you all to this particular lecture on C++, basically numerical methods implementation in C++. So in this lecture, we will be learning that how to write code for solving system of linear equations, especially for the cases when the system is diagonally dominant. Now I'm having one problem with me. I'm having three different numerical problems. Three different system of equations, three different linear equations, and these are diagonally dominant. Now, if you look this matrix form of it, then you can see that the diagonal element are the dominant in their respective rows. That means the the value of the diagonal element should the magnitude of it should be either more or at least equal to the sum of the magnitude of off diagonal elements. So if this is the case, then the system can be easily solved using iterative methods like Jacobi and Gauss-Seidel. So in this lecture, we will be learning about the Jacobi method, and in the next one, we will be solving the same problem using Gauss-Seidel. Once you know Jacobi, then the Gauss-Seidel becomes very easy to comprehend and understand. So first, what we'll do is we will pick the diagonal element coefficients on one side and keep rest on the others. So here from the first equation, we have kept x1 on one side and rest on the right side. From the second equation, we bought x2 on the left hand side, whereas from the third equation, x3 has been taken out and the respective equations look like this. This is one of the major steps when it comes to solving system of linear equation iteratively. Then once this has been done, then what we'll be doing is we will be now jumping to Jacobi iterative method. This is a very elegant way, one of the very elegant way of solving system of linear equations iteratively. Now, in this particular method, what we do, we first set up the guess values for x1, x2 and x3. Doesn't matter what value you take, you can take any value. Normally what people do is they take 0 if they are not sure what the value is going to be. Then what they do, they come to this particular system, and where it is x2 x3 in this right hand side, they replace it by guess values, as you can see here. So x2 is replaced by x2 guess, x3 is replaced by x3 guess, x1 is replaced by x1 guess, and so on. So based on the guess value, new values of x1, x2, x3 are evaluated. Once they are evaluated, then the error is evaluated using the new evaluated value and the old guess value for all the variables that is x1, x2 and x3, like this. Once the error is evaluated, then you have to check whether the error is less than the converging criteria or not. If it is yes, that the error has been reduced below the convergence criteria, then whatsoever you have got as x1, x2, x3, that is your answer. If it happens that your answer is no, that means your error is more than the converging criteria epsilon, then in that case, x1, x2, x3 evaluated in that particular iteration will become the guess values for the next iteration, and this will go on till this is met. So let us write the program for this. So before that, what we'll do is we will write them side by side, and now these are the equations. So first, this also. So the first thing which I will be doing is I have to write the guess values for x1, x2 and x3. This. Okay. So first create variables double x1 guess, x2 guess, x3 guess. Okay, and as well as create those x1, x2 and x3. You could have also done the same thing using arrays, but I'm just making you understand the topic. So, and the number of variables are not too high, so we can do it like this. So now the guess value has to be supplied. So let's say x1 guess is equal to x2 guess, and that is equal to x3 guess, and the whole value I am taking it as 0. This is a valid C++ expression. If you run it, there is no error. So what will happen? X3 first will be evaluated by x3 will gain this value 0, then x2 will become same equal to x3, then x1 will become equal to x2. So in this way, this particular statement works. Once this is done, then you have to evaluate this, and this has to be evaluated continuously. So we have to use a loop. Okay. So let us say while true, make it true always, and then evaluate x1. So x1 will be equal to 5 plus x2 guess, then minus x3 guess, and this whole is divided by 5. So this is our first equation. The second equation is x2 is 6 minus x1 guess plus 5 times x3 guess, and this whole is divided by 10. Then x3, it is equal to 3 minus x1 guess plus 2 times x2 guess, and this whole is divided by 4. So once you know the values of x1, x2 and x3 based on the guess works, then what has to be done? Then error you should evaluate. Okay. So now let us evaluate this error. So double error, and that is equal to what? Absolute value of the difference of new evaluated x1 and the x1 guess. Then plus, let us copy this, and let us do it for x2, and then plus, then finally for x3. Once this is done, then you have to check for the convergence. That is, if the error is less than some converging criteria, let's say it is 10 to the power minus 5, then your answer, the roots are C out and x1, and then let us write comma, and why not to copy this? Oops, control Z, what I have done, I should have been copying. Okay, then this should be x2 and this should be x3. Now if the error is not less than this value, then what we have to do? Else we have to set the new values as the guess. So x1 guess will be x1, x2 guess will be x2, and x3 guess will be x3. Once this has been done, everything is done. So now you have your simple code for finding out the values of unknown in system of linear equations, and the method which we have adopted is what we call as Jacobi method, Jacobi iterative method. So if you run it now, then this will run forever. Why? There is a problem, because we have said that you just print the value once this converges, but we haven't told the program that what to do after it. So what we have to do? We have to break here. So remember that once the condition always met, then you always have to break it. Okay, now if you run it, then you will get the answer 1, 1 and 1. So friends, in this way you can use your knowledge of programming as well as mathematics to model numerical methods. Okay, so in this lecture till this point only. In the next lecture we will be using Gauss-Seidel, and that is a very easy thing now because we already have the understanding of Jacobi method. So thank you very much for watching it.